In this lesson, we're going to continue our study on dividing rational expressions. Now, in the previous lesson, just to remind you, in the previous lesson, we looked at dividing rational expressions, which involved just monomial factors. So just make sure that you go back and you look at all these examples that dealt with dividing monomial factors. All right, so in this lesson, though, we're going to look at rational expressions that have polynomials that have more than one term, so two or more terms. Okay, so for example, let's look at number 1. So the directions will say basically divide. Now you all know, based on our study with rational expressions, that you want to make sure that all your rational expressions are simplified. So the directions will say divide. Okay, so number 1, we have 6, I'm sorry, wrong one. So number 1, we have 15a minus 45, so 15a minus 45, divided by 4a, and that rational expression is being divided by this rational expression, 5a minus 15, divided by 6a cubed. Okay, so notice that these rational expressions are made up of monomial factors and also binomial factors in this case. So you have polynomials that have one term or more than one term. Okay, so remember in our previous lesson, what you have to do when you're dealing with division, dividing polynomials, is you want to make sure you change it to a multiplication problem. So I'm just trying to quickly get to that last lesson. So remember, this is what we did. So you learned in a previous course that when you divide fractions, you want to change it to multiplication problem. So that's where you take the reciprocal of the fraction that follows the division symbol. And so that's what we did here. So the first step, remember the first step, just like you did in a previous lesson, step number 1 will always be to change the division problem to multiplication. That is always going to be step number 1. Okay? All right, so let's go and do that. So the first step we're going to do is change this division problem to multiplication. And once we change the multiplication, then the rest of the work is what you've done, is what you were doing with all of these previous lessons. So all of these lessons that you've learned with multiplying rational expressions is what you're going to use at that point. Okay? So the only new thing you have to remember is that you have to change division to multiplication. You have to change this to a multiplication problem. And that's always going to be step 1. All right, so here we go. So whenever you change it to multiplication problem, remember the first rational expression stays as it is. So that's going to equal 15a minus 45 divided by 4a. Change the multiplication. So remember, when you change the multiplication, always remember multiply by the reciprocal. So the reciprocal of this rational expression is 6a cubed divided by 5a minus 15. Okay? All right, so that's the first step. And the rest is what you've learned before. So the rest, if you go back to your steps from a previous lesson, the rest of the steps is this right here. So the rest is you're going to factor all polynomials, then you're going to reduce, and then you're going to write your answer as a rational expression made up of the factors. Okay? All right, so in this numerator, I can factor out, looks like a 15. So when I factor out a 15, I'm going to get 15 times a minus 3. Okay? The denominator is a monomial, so I'm going to leave it as it is. In the second rational expression, the numerator is a monomial, so I'm going to leave it as it is. But the denominator looks like I can factor out a 5. So when I factor out a 5, I get 5 times a minus 3. All right, so that's where I'm at. So the first thing I had to do was to factor all polynomials. Okay, so now you're going to look at all of your factors that are in the numerators, and you're going to see if you can reduce it with any factor in the denominator. And it's very important. It is very important you know what your factors are. Your factors are 15, that's the first one. The second factor is a minus 3. The third factor is 6. And the fourth factor is a, and you have 3 of those. In the denominator, you have 4, you have a, you have 5, and you have a minus 3. Okay? So it's very important to know what your factors are. Okay, so let's start with 15. So I have 15. Will 15 reduce with any factor that's in the denominator? Yeah, it will, with the 5, right? So you're going to say 5 and a 5 is 1, 5 and a 15 is 3. All right, now notice, don't just strike out the number or the expression. Just make sure you put a 1 in its place, okay? The next factor is an a minus 3. Do you see an a minus 3 occurring as a factor in the denominator? Yep, right here. So when I divide those out, I get factors of 1 in their place. The next factor is a 6. Will 6 reduce with a factor that's in the denominator? Yes, it will. 6 will reduce with 4. They have a 2 in common. So 4 divided by 2 is 2. 6 divided by 2 is 3. The next factor is a cubed and have 3 of those factors. All right, now listen carefully to our discussion. We keep doing this with every lesson. So I have 3 factors of a in the numerator, right? So think about this. I have a times a times a. In the denominator, I have 1 factor of a. And so if I reduce this, then a divided by a is 1, a divided by a is 1. And that's all I can do. So I get 1 times a, which is a squared. So basically, and again, most students will not write this out. In their mind, they're thinking this. They're thinking, okay, I have 3 factors of a. I have 1 factor of a, so that one will divide into this one. So a into a is 1. And that a here, when I divide it into the 3 factors I have here, I'm left with 2 of them. And that's what this is. Okay, so in your mind, this is what you would have. And so that's it. So then you just write your answer now as one rational expression. I want you to notice, so you see how messy it's becoming? So just be careful when you have a lot of factors that you're striking out. So just be careful with your work. You don't because you can easily miss something here. Okay, so I have 3 times 1 times 3 times a squared. So that's going to be 3 times 3 is 9. So it'll be 9a squared divided by 2 times 1 times 1 times 1, which is 2. And so there's your answer. Okay, so that's number 1. Okay, number 2. Number 2, we have 4x plus 20y divided by 3x minus 12y. And that rational expression is being divided by this rational expression, 5x plus 25y divided by 2x minus 8y. All right, so I want to divide those 2 rational expressions. So just as you were doing before, first step is to always change division to multiplication. That's a first step, step number 1. So remember from previous courses, the first thing you're going to do, and I say from previous courses, I'm really referring to when you divided in previous courses, when you dealt with 2 fractions that were numbers, they were numerical fractions. So remember, you changed it to multiplication by taking the reciprocal of this fraction. Okay? All right, so I get 4, so it's going to equal 4x plus 20y divided by 3x minus 12y times the reciprocal of this fraction. So that will be 2x minus 8y divided by 5x plus 25y. Okay? All right, so that was the first step. And then the rest is what you've done before. So you're going to factor next. You're going to factor all of your polynomials. So in the numerator here, it looks like I can factor out a 4. So I get 4 times x plus 5y. The denominator looks like I can factor out a 3. So you get 3 times x minus 4y, right? In the numerator over here, it looks like I can factor out a 2. So I get 2 times x minus 4y. In the denominator, it looks like I can factor out a 5. So I get 5 times x plus 5y. Okay? All right, so now let's go ahead. So I factor. The next step is to reduce. So my first factor here is a 4. Will 4 reduce with any factor that's in the denominator? No, because your factors are 3, x minus 4y, 5, and x plus 5y. The next one is x plus 5y. Do you see an x plus 5y occurring as a factor in the denominator? Yep, right here. So those are going to divide out. So remember, don't just cross them out like this. You got to remember that's a factor of 1 because x plus 5y divided by x plus 5y is 1. So you got to say 1 divided by 1, just like that. Okay? You're left with factors of 1. The next factors are 2. Do you see a factor of 2 occurring in the denominator? Nope. The next factor is x minus 4y, and I see an x minus 4y here. So those will divide out. And so therefore you get as your answer, you're going to get 4 times 1 times 2 times 1, which is 8. 3 times 1 times 5 times 1, which is 15. And so there's your answer, 8 divided by 15. All right? Okay, number 3. So number 3, we have 16d squared minus 9 divided by d squared minus 16. Now that rational expression is being divided by this rational expression, 4d plus 3 divided by d minus 4. All right, so if you look at what you have, okay, so I was making sure I wrote that problem correctly, so I think I did. So if you look at your have, remember you got to change this division problem to multiplication, first step. So we're going to have 16d squared minus 9 divided by d squared minus 16 times the reciprocal. So d minus 4 divided by 4d plus 3. Okay, now let's go ahead and factor. So in terms of these four parts here, the two numerators and the two denominators, the only thing I can factor are these two here. So this right here, you got to recognize that that's a difference of 2 squares. So we're going to get 4d minus 3 times 4d plus 3. The denominator, that's the difference of 2 squares as well. So I'm going to get d minus 4 times d plus 4. And then I can't do anything with these two, so I'm just going to rewrite it. So d minus 4 divided by 4d plus 3. Okay, now the next step is to reduce. So you're going to take each of these factors there in the numerator and see if you can reduce it with a factor that's in the denominator. So I have a 4d minus 3. Do you see a 4d minus 3 anywhere in the denominator? No, you don't. I see a 4d plus 3. Do you see a 4d plus 3 in the denominator? Yes, so those will divide out. So you're left with factors of 1. I see a d minus 4. Do you see a d minus 4 in the denominator? Yep, right here. So those will divide out. And that's it. That's all you can do. So the answer is going to be 4d minus 3 times 1 times 1. So that's 4d minus 3 divided by 1 times d plus 4 times 1, which is d plus 4. And so that's all you do. All right, so it's very simple, and it's not that bad. You're getting more proficient with this only because once you do this step, the rest is what you've done previously. Okay, number 4. Number 4, you have w squared minus 4w minus 21 divided by w squared minus 25, and that rational expression is being divided by this one, w minus 7 divided by w minus 5. Okay? All right, so again, the first thing, whenever you're dividing rational expressions, the first thing is to change this to multiplication problem. So I get w squared minus 4w minus 21 divided by w squared minus 25 times the reciprocal. So that's going to be w minus 5 divided by w minus 7. Now let's go ahead and factor these two numerator, this numerator and this denominator. These I can't do anything with in terms of factoring. So over here, I'm going to go ahead and do the two binomials. So w times w is w squared. The last sign's negative, so that means these signs in here are different. And maybe I need to change those. And I need a negative for w. So let's see, 7 and 3. And I need 7 to be negative and 3 to be positive. And again, always check. The outer's a negative 7w, the inner's a positive 3w, and when I add them up, I get negative 4w. The denominator, that's the difference of 2 squares, so I'm going to get w minus 5 times w plus 5. Okay? Times, and then over here I'm going to have w minus 5 divided by w minus 7. All right, so that's where I'm at. So now we're going to reduce. So I factored, now reduce. So my first factor I see is a w plus 3. Is there a w plus 3 occurring in the denominator? No. The next factor is a w minus 7. I see a w minus 7 here, so those will divide out. I see a w minus 5. So there's a w minus 5 here. Those will divide out, and that's all you can do. So your answer is w plus 3 times 1 times 1 is w plus 3. 1 times w plus 5 times 1 is w plus 5. So that's your answer. Okay? All right, let's get number 5. Number 5, we have 3y minus 5 divided by 3y to the 5th power minus 5y to the 4th. And that's being divided by 8y squared minus 2y minus 3 divided by 4y squared, y to the 4th minus 3y to the 3rd power. Okay? All right, so we have this rational, we're dividing these two rational expressions, so let's go ahead and change the multiplication. Step number 1. So 3y minus 5 divided by 3y to the 5th minus 5y to the 4th times the reciprocal here, so that's going to be 4y to the 4th minus 3y to the 3rd divided by 8y squared minus 2y minus 3. All right, so the first thing we did was change it to multiplication problem. Step number 1. All right, so once you change the multiplication problem, next step is to factor. So this numerator I can't factor, but this denominator I can, so I'm going to rewrite the numerator as it is. The denominator looks like I can factor out a y to the 4th, so I get y to the 4th times 3y minus 5, okay? And right away you can see those will divide out. Times, and then over here, it looks like I can factor out a y to the 3rd power, and I'm going to get 4y minus 3. And always double check, y to the 3rd times 4y is 4y to the 4th, and then y to the 3rd times a negative 3 is a negative 3y to the 3rd. Now the denominator, the GCF is 1, so I'm going directly to the two binomials. And for that one, it looks like I'm going to try 4y and 2y, so that's going to give us 8y squared. And then the last term is a negative 3, so these signs in here are going to be different, and I need a negative 2y. So it looks like I'm going to put the 3 here, the 1 here, and it looks like the 3 is going to be negative and the 1 is going to be positive. Let's double check. 4y times 2y is 8y squared. A negative 3 times a positive 1 is a negative 3. The outer is a 4y, the inner is a negative 6y, and when I add them up, I get negative 2y. Okay, so now let's go ahead and reduce. So I have a 3y minus 5. I see 1 here, so those divide out. All right, I see a y, and there are 3 factors. Will any of these factors reduce with any factors of y in the denominator? If it does, it's going to be this one right here, right? Because that has how many factors of y? 4. Okay, so I have more down here. So that means all of these will divide out with 3 of these. And so I had 4 of them, so I'm left with how many? 1. So y to the 1st. The next factor is 4y minus 3. I see 1 here, so those will divide out. And that's all you can do. So your answer looks like it's going to be 1 times y to the, see, you have to be careful with all the markings. 1 times 1 times 1 is 1. The denominator, y to the 1st times 1 times 1 times 2y plus 1 is y times 2y plus 1. That's all you can do. See that? Y times 1 times 1 times 2y plus 1 is y times 2y plus 1. And again, leave your answer in factored form. Don't distribute. Just leave it like this. That's going to be important at some point later on. So just leave it alone. All right, so that's number 5. Number 6, we have x squared minus 3x minus 18 divided by x squared plus 7x plus 12. And that's being divided by, now here watch how this looks. So this looks like this. So don't let it throw you off. Okay, so don't let this throw you off. You may say, well, that looks totally different from any of the others, because all the others, when we had a rational expression, I could visibly see a numerator and the denominator. Numerator and the denominator, right? Okay, well, look at this right here. It's kind of like saying, I want you to think about this, it's kind of like saying, and let's kind of review something, if I had 4/5 divided by, let's say, 3, okay? Well, remember what you did. So when you dealt with this in a previous course, you basically said, all right, I'm going to change this to a multiplication problem. So I'm going to get 4/5 times the reciprocal. You may say, well, that's not a fraction. Well, you can rewrite 3. You can rewrite 3 as 3/1, couldn't you? And so then you would say, well, the reciprocal of 3 is 1/3. So over here, you would do the same thing. So I'm going to go ahead and rewrite this just to kind of explain it again. So basically what you need to do is think of this as x squared plus 2x minus 24 divided by 1, just like you did here. Okay? And now you can see, hey, okay, I do have a rational expression, so I know how to take the reciprocal of that. All right? Okay, so let's go ahead and change this to a multiplication problem. So I get x squared minus 3x minus 18 divided by x squared plus 7x plus 12 times the reciprocal. So 1 divided by x squared minus 2x minus 24. Okay? All right, now once you change the multiplication, then let's go ahead and factor. So when I factor this, it looks like I'm going to get in the numerator, all right, the GCF of all of these is 1. So I'm going to go directly to the two binomials. So when I go to the two binomials, for that one, it looks like it's going to be x minus 6 times x plus 3. And if you check it, it does work out. In the denominator, it looks like that's going to be x plus 4 times x plus 3. And over here, I'm going to have 1 divided by the polynomial here. I can factor that as x minus 6 times x plus 4. Okay? All right, so I factored the numerators, I factored the denominators, I factored all the polynomials. Now the next step is to reduce. So my first factor I see is an x minus 6. Can I reduce it with any factor down there? Yeah, because I see it right here. So we divide those. You get 1s in their place, factors of 1. The next factor is x plus 3. I see one right here. Okay, divide those out. And then you're done. So you get 1 times 1 times 1, which is 1. So the numerator is 1. The denominator is x plus 4 times times 1 times 1 times x plus 4. All right, so you can write as x plus 4 times x plus 4. Again, don't multiply it out. Leave it alone. Leave it like this. Now, you could have also noticed, hey, that those two binomials are the same. So if I wanted to, though, you could have rewritten it as x plus 4 to the second power. So x plus 4 squared. Okay? All right, so that was number 6. All right, let's look at number 7. So number 7, we have b squared minus 25 divided by, divided by b squared plus 2b minus 15. And that rational expression is being divided by this one, 5 minus b divided by b squared plus 4b minus 21. All right, so if I look at if I look at what I have, I'm dividing two rational expressions, so I've got to change this to multiplication, right? So I get b squared minus 25 divided by b squared plus 2b minus 15 times the reciprocal. So I'm going to get b squared plus 4b minus 21 divided by 5 minus b. All right? So now the next step is to factor your polynomials. So factor the numerator. This numerator, that's the difference of two squares. So I'm going to get b minus 5 times b plus 5. The denominator, the GCF is 1, so I'm going to go directly to the two binomials. So that looks like that's going to be b plus 5 times b minus 3 times here, we go directly to two binomials, so that's going to be b plus 7 and b minus 3. And that's a linear factor, so I'm going to leave it as 5 minus b. All right, so that's where I'm at. Okay, so now let's reduce. So my first factor I see is a b minus 5. I don't see a b minus 5 as it is down here, right? But what do you notice? You see its opposite, 5 minus b. So that means that when I divide those out, remember, opposites, this will be a factor of 1, and this will be a factor of negative 1. Okay? So remember, we tend to put the positive 1 in the denominator and the negative 1 in the numerator. The next factor is a b plus 5. I see one here, so those will divide out. The next factor is a b plus 7. I don't see a b plus 7 anywhere in the denominator. Next factor is a b minus 3, and I see one here. And so therefore, we get this. We get negative 1 times b plus 7 times 1, so that's negative 1 times b plus 7. Divided by 1 times 1 times 1 is 1. Now, I want to remind you, so you see how you have that 1 in the denominator? Then just rewrite it as the numerator, because the numerator divided by 1 is just what that expression is. So negative 1 times b plus 7. So you can leave your answer like that. Okay? I want you to also remember that negative 1 times b plus 7 means the same thing as this right here. So the opposite of b plus 7, they mean the same thing. Okay? Because remember, if there's no number listed, it's understood to be a 1. Now, if you want to, remember how I kept telling you, don't distribute, leave the answer as it is in factored form. Don't distribute, leave the answer in factored form. Since this is just a negative 1, then you can just go ahead and distribute, but it does not matter. Just be careful you distribute, though. Remember, that's going to be negative b minus 7. Okay? All right, so that's number 7. Number 8, we have y squared minus 49 divided by y to the 4th. And that rational expression is being divided by this rational expression, y to the 4th minus 7y cubed divided by y minus 6. Okay? All right. So then we're going to change this to multiplication problem. So I get y squared minus 49 divided by y to the 4th times the reciprocal, y minus 6 divided by y to the 4th minus 7y cubed. Okay? All right, so now once you change the multiplication problem, the next step is to factor. So I'm going to get, that's the difference of two squares, so I'm going to get y minus 7 times y plus 7 divided by y to the 4th times, that's a linear factor, I can't do anything with that, the GCF is 1. And here, though, I can factor out a y to the 3rd, so I get y to the 3rd times y minus 7, right? Always check. Y to the 3rd times y is y to the 4th. Y to the 3rd times a negative 7 is negative 7y to the 3rd. Okay, now we can reduce. So I have y minus 7. I see one here. A y plus 7. I don't see a factor y plus 7 in the denominator, and I don't see a factor y minus 6 in the denominator. So therefore, the answer is going to be 1 times y plus 7 times y minus 6. So in other words, y plus 7 times y minus 6. The denominator is going to be y to the 4th times y to the 3rd times 1. So remember, though, y to the 4th times y to the 3rd, when you multiply like bases, you add exponents. So that's going to be y to the 7th. Okay? All right, so that's number 8. Number 9. All right, number 9, we have x squared minus 64 divided by 25x squared minus 16. And that's being divided by, that rational expression is being divided by this rational expression, x minus 8 divided by 4 minus 5x. All right, so let's see what we get. So I have a division problem here, so I need to change it to a multiplication problem. Okay, and so when I change that to a multiplication problem, I'm going to get x squared minus 64 divided by 25x squared minus 16 times the reciprocal, so 4 minus 5x divided by x minus 8. All right, so once you change the multiplication problem, remember the next step is to now factor. So this is the difference of two squares, so I'm going to get x minus 8 times x plus 8. The denominator is also the difference of two squares, so I'm going to get 5x minus 4 times 5x plus 4, right? Times, and then I can't do anything with these, so I'm going to rewrite them, 4 minus 5x divided by x minus 8. All right, now let's go ahead and reduce. So I have an x minus 8. I see one here, so I can reduce. Those divide out. I have an x plus 8. I don't have an x plus 8 anywhere in the denominator. I have a 4 minus 5x. I don't see a 4 minus 5x, but I see its opposite. So that means that when I divide those, one's going to be positive 1, the other one's going to be a negative 1. Okay, notice I put the negative 1 here. And we're done. You just got to now rewrite your answer. So 1 times a negative 1 is a negative 1 times this. So I get negative 1 times x plus 8 divided by 1 times 5x plus 4 times 1 is 5x plus 4. Okay? Now, there are a couple ways to write this answer, and so I want to talk about each of those ways. Okay, so let's kind of review something as we go through the discussion. So, do y'all agree that negative 1 times 6 divided by 5 means negative 6 divided by 5, right? Just like this. Okay? Do y'all agree that also means that this right here I can rewrite as a negative fraction, 6/5. So just like this. In other words, you can you see where the numerator is a negative 6. Okay, here what you have here, this means the opposite of 6/5. So this and the opposite of 6/5. So a negative 6/5 means the same thing. Here, though, we tend to think of this as a positive 6, and this is a positive 5, and that this fraction is negative. But it does not matter. It's just the way you want to write it. So what I'm saying here is this. If you want to, you can rewrite this as negative x plus 8 divided by 5x plus 4. Okay? Because that's the same discussion we had a while ago. Or if you want to distribute the negative, you can. So you can rewrite this as negative x minus 8 divided by 5x plus 4. Or you can use this idea here. Or you can use this idea here. So in other words, you can write this as x plus 8 divided by 5x plus 4 with a negative in front. Okay? And so just know that those are different ways of writing the same thing. Okay? All right, so that's number 9. Let's look at number 10. So number 10, we have a squared plus 9a plus 14 divided by a squared minus 12a plus 36. Divided by, so that rational expression will be divided by this one, a squared plus 14a plus 49, and the denominator is a squared plus a minus 30. All right? Okay, so change that to multiplication. So if I change that to multiplication, we're going to get a squared plus 9a plus 14 divided by a squared minus 12a plus 36 times the reciprocal, so it'll be a squared plus a minus 30 divided by a squared plus 14a plus 49. All right? So once you change the multiplication, then you're going to factor each of those polynomials. So each of those, the GCF is 1, and they're all factorable. And so in the numerator, when I factor that numerator, I'm going to get a plus 7 times a plus 2. The denominator, when I factor it, that's going to be a minus 6. Nope, not a minus 6. Yeah, a minus 6, that's right. So because 6 times 6 is 36. So a minus 6 times a minus 6. All right, so it's negative 6 times negative 6 is 36. And then a negative 6a and a negative 6a is a negative 12a. All right, over here, looks like I'm going to get a minus 5 times a plus 6. Yep, that works. And then the denominator looks like that one's going to be a plus 7 times a plus 7. Okay? All right, now let's go ahead and reduce. I see a factor of a plus 7 up in the numerator and 1 in the denominator. So those will divide out. As I don't see a factor of a plus 2 in the denominator, so that's going to stay as it is. And a minus 5, I don't see a factor of that. And a plus 6, I don't see a factor of that. All right, so basically, the only thing I could have factored out was this. I could have reduced was this. So the answer is going to be this times this times 1. So it'll be a plus 2 times a minus 5 times a plus 6 divided by a minus 6 times a minus 6, or I can write as a minus 6 squared, right? Times a plus 7. Okay? And again, leave it in factored form. I would hate for you to multiply this out. You could easily make a mistake along the process. So leave it like this. Do not multiply it out. Leave it in factored form. So there's your answer. Okay, number 11. So when we do number 11, you got to remember how to factor by grouping. So number 11, look at what we have. We have xy minus 8x plus 2y minus 16 divided by xy plus 3x minus 8y minus 24. So you see you have 4 terms here. So we're going to try grouping in a little while. That is being divided by xy plus 4x plus 2y plus 8, and the denominator is xy plus 4x minus 8y minus 32. All right, so there's a lot. So all of our numerators and all of our denominators are going to involve grouping. So there's going to be a lot of work here. So what I would do is, since that's going to involve quite a bit of work, just go off to the side and figure each one out. So let's start with that numerator. So my numerator, I have xy minus 8x plus 2y minus 16. So I'm going to group the first two and the last two. So in the first group, I can factor out an x, and I get y minus x times y minus 8. In the second group, I'm going to factor out a 2, and I get y minus 8. And then notice I can factor out a y minus 8 from there. So I get y minus 8 times x plus 2. All right, so that's this numerator. So that's going to equal, so I'm going to go ahead and put this now here. So, so remember the first thing we were supposed to do was change the multiplication problem. So let me do that. So let me change this multiplication problem. So I'm going to rewrite this. Xy minus 8x plus 2y minus 16 divided by xy plus 3x minus 8y minus 24 times the reciprocal. So xy plus 4x minus 8y minus 32 divided by this. So xy plus 4x plus 2y plus 8. All right, so once you change the multiplication, then let's go ahead and factor the numerators and the denominators. So I factored this numerator, so that's going to be this. So y minus 8 times x plus 2. All right, let's go ahead and deal with this denominator. So let's go ahead and factor it. So I get xy plus 3x minus 8y minus 24. And so I'm going to group the first two and then group the last two. In the first group, I can factor out an x. I get x times y plus 3. The second group, I can factor out a negative 8. Remember, I always factor out the negative sign, that middle sign. And I'm going to get negative 8 times y, and a negative 8 times a positive 3 is a negative 24. So notice I can factor out a y plus 3. So I get y plus 3 times x minus 8. So that's going to go here. So y plus 3 times x minus 8. Okay, times. All right, now let's do this one. So now we're going to do this one now. So here I have xy plus 4x minus 8y minus 32. So let's group the first two and the last two. And in the first group, I can factor out an x. I get x times y plus 4. The second group, I can factor out a negative 8, and I get y plus 4 as well, because a negative 8 times a positive 4 is a negative 32. So that can factor out a y plus 4. And so when I factor out a y plus 4, I'm going to get y plus 4 times x minus 8. So that's going to be the numerator. So that's going to go here. So that will be y plus 4 times x minus 8. Okay. Now the denominator, when I factor it, I'm going to get xy plus 4x plus 2y plus 8. So let's go ahead and factor that one. So I can factor out an x, and so I get x times y plus 4. Here I'm going to factor out a positive 2, and I get positive 2 times y plus 4 as well. So then I could factor out a y plus 4, and when I factor out the y plus 4, I get y plus 4 times x plus 2. All right, so that's going to go here. So y plus 4 times x plus 2. Okay? All right, now once you factor, so notice there's quite a bit of work, right, for that one. Okay, now the rest is easy because all I need to do is look for common factors. So y minus 8, I don't see a y minus 8 in the denominator. X plus 2, I see an x plus 2 as a factor, so those will divide out. Y plus 4, I see one here, those will divide out. X minus 8, I see one here, those will divide out. And that's it. So your answer is going to be y minus 8 times 1 times 1 times 1 is y minus 8. And then y plus 3 times 1 times 1 times 1 is y plus 3. Okay? All right, so that's number 11. Okay, let's look at number 12. So number 12, we have this for number 12. We have x squared plus 2xy minus 3y squared divided by x squared minus 3xy plus 2y squared. And that rational expression is being divided by this one, x squared plus 4xy plus 3y squared. And the denominator is x squared plus 2xy minus 8y squared. Okay? All right, so again, the first thing we're going to do is change this to a multiplication problem. So I get x squared plus 2xy minus 3y squared divided by x squared minus 3xy plus 2y squared times the reciprocal, x squared plus 2xy minus 8y squared divided by x squared plus 4xy plus 3y squared. Okay? All right, so first thing you have to do is change this problem to multiplication problem. So you multiply by the reciprocal. Okay, so now we're going to factor. So all of these, notice that all of these have two variables in it, an x and a y. The GCF of each one is 1. So we're going to go directly to the two binomials. So in the first numerator, looks like this one's going to be x plus 3y times x minus y. And I always double check. The outer is a negative xy, the inner is a positive 3xy, and when I add them up I get 2xy. And 3y times a negative y is a negative 3y squared. Okay, so always check. The denominator looks like that's going to be x minus 2y times x minus y. Okay? A negative xy and a negative 2xy is a negative 3xy. Okay, the numerator here, let's go ahead and factor that. Looks like that's going to be x plus 4y times x minus 2y. So let's check that one. A positive, remember the last sign's negative, right? So that means these signs are different. And let's double check. A positive 4y times a negative 2y is a negative 8y squared. The outer is a negative 2xy. The inner is a positive 4xy. And when I add them up, I get a positive 2xy. Okay, the denominator, that's easy because they're all positive anyway. So that's going to be x plus 3y times x plus y. Okay, so I factored the numerators and I factored the denominators. So now let's go ahead and reduce. So the first factor I see is an x plus 3y. Do I see an x plus 3y in the denominator? Yeah, right here. So those will divide out. Remember, don't just strike it out. Cross it out. Make sure you understand that you have ones in their place. Factors of 1. The next factor is an x minus y. I see one here. The next factor is an x plus 4y. I don't see one anywhere in the denominator. The next factor is x minus 2y. I see one here, so those will divide out. So therefore, the answer is just 1 times x plus 4y times 1. So the numerator is just x plus 4y. The denominator is 1 times 1 times 1 times x plus y, so that's just x plus y. So there's your answer. Okay? All right, number 13. Number 13, and that'll be the last one we're going to... Oh, actually, there's two more. So two more. So here's 13. So 13, we have we have, now again, that's going to look like a previous one we just did. So we have y squared minus 49 divided by y squared plus 4y minus 21 divided by y squared plus 7. Okay? All right, so it's just like the one we had a while ago, but it was on the other side. So again, just rewrite this. First of all, before you change it to multiplication, rewrite this as y squared minus 49 divided by 1. So this is this, okay? And now you will see what you need to do. Okay, so all I did was I just rewrote this y squared minus 49 as y squared minus 49 divided by 1. Okay? All right, now we're going to change the multiplication problem. So when I change this multiplication problem, I'm going to get y squared minus 49 divided by 1 times the reciprocal. Y squared plus 7 divided by y squared plus 4y minus 21. Okay? Now we're going to reduce. So now reduce, now we're going to factor, excuse me. When I factor, this is the difference of two squares. So I get y minus 7 times y plus 7 divided by 1 times, I cannot factor this, so I'm going to leave it as y squared plus 7, okay, divided by, and then here, looks like when I factor that, I'm going to get y plus 7 times y minus 3, okay? Now let's go ahead and reduce. So it looks like I can reduce these, right? There's a y minus 7 here, but I don't see a y minus 7 in the denominator, and that's a y squared plus 7. I don't see one in the denominator. So therefore, your answer is just, don't forget, that's factors of 1, okay? So your answers are y minus 7 times 1 times y squared plus 7. So in other words, I'm going to write this as y minus 7 times y squared plus 7 divided by 1 times y minus 3, and that's y minus 3. Okay? Again, don't factor it out. I'm sorry, don't multiply this out. Leave it in factored form. Okay, finally, number 14. So let's look at 14. So that should give you enough problems to understand what to do with division of rational expressions. So 14, you have 6x squared minus 7x minus 3 divided by x squared minus 3x minus 10. That rational expression is being divided by this rational expression, and that's 9 minus 4x squared divided by 2x squared plus 7x plus 6. Okay, so the first thing you're going to do is change this to multiplication problem. So when I change that to multiplication problem, I'm going to get 6x squared minus 7x minus 3 divided by x squared minus 3x minus 10 times the reciprocal. So that's going to be 2x squared plus 7x plus 6 divided by 9 minus 4x squared. Okay? Now let's factor. So when I factor the numerator, the Gcf is 1, so I'm going to go directly to the two binomials. And when I do that, it looks like I'm going to get 3x and 2x. The last sign's negative. These signs in here are different. And it looks like for that one, that's going to be 3x plus 1 and then 2x minus 3. Okay, and that should work out. So let's see, negative 9x, positive 2x is a negative 7x. All right, the denominator looks like that's going to be x minus 5 times x plus 2. Okay, all right, the numerator over here looks like, now that one's easy because they're all positive and 2 is a prime number, so it'll be easy to deal with. So for that one, looks like that's going to be 2x plus 3 times x plus 2. Okay, and always double check. 3 times 2 is 6. The outer is 4x. The inner is 3x, and I get 7x. And this denominator, that's the difference of two squares. So I'm going to get 3 minus 2x times 3 plus 2x. Okay? All right, so now we factor. The next step is to reduce. The first factor I see is 3x plus 1. I don't see a 3x plus 1 anywhere in the denominators. The next factor I see is a 2x minus 3. Do I see a 2x minus 3 in the denominator? No, but what do you see? It's opposite. So when I divide those out, that's going to be a 1. That's going to be a negative 1. Okay? The next factor I see is a 2x plus 3. Do you see a 2x plus 3 in the denominator? Anywhere as a factor in the denominators? Yes, you do. Right here in it. 2x plus 3 is the same as what? 3x plus 2, 3 plus 2x. So those divide out. The next factor is x plus 2. That will divide out with that one. Don't forget, factors of 1. Make sure you put that. And that's all you can do. So therefore, we get this. We get this factor times negative 1, and all the others are 1. So I'm going to end up with negative 1 times 3x plus 1. The denominator is going to be x minus 5 times the products of 1 here. So that's just x minus 5. And that brings us back to something we had earlier. So you can leave your answer like this, right? Or if you want to, you can pull this negative out in front. So in other words, you can rewrite this. You can rewrite this right here as 3x plus 1 divided by x minus 5 negative out in front. Okay, so just remember that this means the same thing as this. Okay? All right, so either one of those is fine. All right, so that is, let me go ahead and find that first page. So this is a lesson dealing with dividing rational expressions, where you're dealing with polynomials that have more than one term. All right. So that's going to be the end of this lesson. So that should give you enough to understand how to deal with this topic, with the topic of multiplying rational expressions and the topic of dividing rational expressions.